Okay, this next section introduces a new concept, which is a parametric relation, and then something you studied in Algebra 2, inverses. So you get some old stuff and you get some new stuff together, and we'll probably have to split it into two pieces. So we'll start with the new information, which is different ways to write relationships. So we already know two ways to write relations. We just probably don't already know them by name because we don't use these terminologies very much. We can write some relations in an implicit form. And an implicit form is a form that has the x's and the y's on the same side of the equation. We see that most often in Algebra 1 when we learn to write equations of lines and we have a standard form of a line. For example, 3x plus 2y equals 6 is the standard form of a linear equation. Another place we see that is with things like ellipses and circles, things that aren't functions, and a lot of times those equations are written in implicit form because they're just easier to work with than solving for y. Second form is explicit form. This is the one that you're most familiar with, and it has y written in terms of x. So it's in the form y equals something in terms of x. So things like y equals 2x squared minus 3x plus 7 would be an explicit form. We sometimes call that function form because then when we put that thing in the calculator, f of x equals, it's already in the form that we need it to be in. So this is probably the most comfortable form that we use. So these are both things we've seen before. So we're going to introduce this third one called parametric form. We don't use it a lot in pre-calculus. Actually, you probably won't even see it again after this time, but it does pop up in calculus a couple of times, and we just wanted to look familiar. A parametric form defines the two variables x and y in terms of a third variable, which is always a t, that's called the parameter. And t, most of the time in application problems, is time. So that's why we have that choice. For example, in a physics problem, we might have some sort of a projectile motion, like somebody shoots a cannon and the ball goes up in the air and then comes back down. And we can model two different motions. We can model how far it's gone horizontally over time, and we can measure how tall it is over time. And those are really two separate components. And in physics, we'd write those as two separate pieces, x and y, both in terms of t. So it does have some direct applications. It also works great for some applications like elliptical motion of planets. We don't get that deep into parametrics in this class, so this is just a bare minimum introduction. Okay, so there's three things you need to know about parametrics. First of all, you need to know in general what they look like and how to generate a graph of a parametric relation with and without a calculator. So, if we consider the set of all ordered pairs x and y that are defined by this parametric relationship, so we'll notice there are two equations, kind of like a system. There's an equation for x, and it's written in terms of t. There's an equation for y, also written in terms of t, and we let t be any real number. So I want to make a graph of this parametric relationship. In order to do that, I need a table of values. So I need to make a table. So I'm just going to squeeze some stuff over here in the corner. Let's make a table with t's. And we're going to generate some x's and y's from those t's. Let's just pick some easy positive and negative numbers and maybe 0. So maybe -3, -2, -1, 0, 1, 2, and 3. Just like we generated tables of values back in early algebra when we were first learning to graph things like lines. And we're going to find the x's and y's that are generated from those parameters. So when t is a -3, I'm going to substitute it into the x equals -3 plus 1. That's a -2. And then I'm going to substitute t equals -3 into the y equation. So negative 3 squared is 9, plus 2 times negative 3 is negative 6. 9 plus negative 6 is 3. And we just do that for all these different t values. So substitute a negative 2 in. Negative 2 plus 1 is negative 1. Substitute negative 2 in for y. Negative 2 squared is 4. Plus 2 times negative 2 is negative 4. And that adds up to 0. Substitute negative 1 in for t in the x. Negative 1 plus 1 is 0. Substitute negative 1 for y equals negative 1 squared is 1. Plus 2 times negative 1 is negative 2. That's negative 1. Put a 0 in. 0 plus 1 is 1 for the x. 0 squared plus 2 times 0 is 0. Substitute t equals 1. In the x, 1 plus 1 is 2. In the y equation, 1 squared is 1, plus 2 times 1 is 2. 1 plus 2 is 3. A couple more. Let x equal 2. T equal 2. X is 2 plus 1, which is 3. And y is 2 squared, 4. Plus 2 times 2, 4 more, which is 8. And I'm actually going to quit there because anything bigger than 8 is not going to fit on my graph anyway. So I'm just going to stop and use these points. Okay, once we generate the table of values, we really want to look at the set of the ordered pairs x comma y. So we really are going to ignore t from this point on because the parameter just kind of is lurking in the background, but you can't see it on the graph because this is an x, y coordinate system. So I'm going to plot the ordered pairs x comma y. So negative 2 comma 3, plot that point. Negative 2, 3 is here. Oh, I'm off. Let's try that again. Okay. And negative 1, 0, which is here. 0, negative 1, here. 1, 0, here. 2, comma 3. 3, comma 8. Does that fit? 1, 2, 3, 4, 5, 6, 7, 8, barely. There's probably a negative 3, comma 8 over here as well that I just didn't get in my table. Alright, so when we make a smooth curve out of those points, we can see that it makes a parabola. So this parametric equation set, this parametrically defined function in this case, that is the equation of a parabola. So it's quadratic in nature. The x-coordinates are linear, the y-coordinates are quadratic, and when you put them together, it creates a quadratic relationship. So the first skill is to be able to substitute some t's in, plot points, and create a graph. That's not new stuff, we've done that before, so pretty basic. We just added in that third value. Alright, second skill. We would like to be able to put that parametric equation into a different form, a form that only has the x and y in it. So we're going to want to be able to eliminate a parameter, t, algebraically, and write the explicit equation for that pair. It's a little off kilter, I'm not sure why, but think of it like as a system of equations. And the goal is to make t go away and squish those together to make something in terms of just x and y. So I'm going to take the simplest of the two, which is probably this first one, x equals t plus 1, and subtract 1 from each side to make something in terms of t. Now t is equal to x minus 1, so x minus 1 can replace t in the other equation for both of those t's. So if I do that substitution, y equals x minus 1 quantity squared, replacing t with x minus 1, plus 2 times replace that t with an x minus 1. And then this is technically rewritten in terms of just x and y. I have removed the parameter. T is not there anymore. So I've done the bulk of the work already. But it's still not simplified, and I kind of like it that way. And if it's a multiple choice test, I have to be able to simplify it anyway, so we'll practice. So let's do some algebra magic. If I multiply x minus 1 times x minus 1, I don't want to take a lot of time for that, so let me just skip to what we would get as a result. If we FOIL that, x squared minus 2x plus 1 will be the result. Then if I distribute the second term, 2 times x is 2x, 2 times minus 1 is minus 2. And then we'll combine some like terms. X squared. The two x's add up to 0. And negative 1, or 1 minus 2 is negative 1. And we get an explicit equation for y in terms of x. And if we look back at that quadratic we had up here, it is just a quadratic x squared that's been shifted down 1, which is what the minus 1 does. So that is the same equation. Okay, one last thing about parametrics. The only other thing you need to be able to do is you should be able to graph this thing in the calculator. So let's take a look at that. Okay, now the question is, can we get the screen light enough? I'm not sure that we can. So we're just going to have to get a little more light on the subject. That might work. Okay, so I'm going to go to my home button, press 1, and don't save the old document, and add a new graph, number 2. Okay, that is a really bad glare. Okay, I hope I'm not making you sick. Okay, so notice it's ready to receive a function, f of x. I don't have a function, f of x. I do not know why I have that glare. Okay, I don't have the function f of x, but if I hit menu, and number 3, which is graph entry edit, this is crazy. Let's see if I can get that to sit still there. Okay, that's a little bit better. There we go. So number 3 in the menu, graph entry edit, we have some options that we've not played with before, one of which is number 3, which is parametrics. And we get an x equals and a y equals. So I'm going to put in x equals 2t, and then go down and put in y equals 3t. Oh, nope, wrong one. I'm putting the wrong equations in. Let's try that again. T plus 1 plus 1 is the first one. I have one we did later in my mind. T squared plus 2t for the y equals. And notice under that we can control what y's we used. So what t's we used. So we went 2, 3. And let's change the lower bound to a negative 3. The t step is actually just a scale, so it's going to plot a new value every 1300ths of a t, and then connect the dots. So we're just going to get a whole bunch of points and connect the dots. Alright, so everything looks the same as it does on paper, except that we have to control what t's we put in. And when we hit enter, there's the parabola. But notice we don't get the whole parabola, because anything that corresponded to a t smaller than 3 is not being graphed. So I actually would need to see some smaller t values in my domain. Well, actually that's not really the domain, in my parameter, to get the full graph on the picture. But we're not really worried about that right now. We just want to see that that is how we get that parametric graph on the calculator. We can always play with our t values to get a more complete graph. We just need some smaller t's in our set. Okay, so be able to make a table of values, plot points and connect dots by hand, and eliminate a parameter, and last but not least, you can check it on the calculator. You can even go back to menu, graph entry edit, change it back to function, number 1, and graph the explicit form that we wrote, x squared minus 1, and overlay those two, and see that they are actually the same graph, just two different ways to write the same equation. Okay, so that's everything you need to know about parametrics for now. So we're going to stop this video and we'll pick up the next segment with the inverses on this note page.